Hi everyone, welcome to another tutorial on LSED. This video is going to be dedicated to the first grade operation leader that I work with, and it was my privilege to learn the basics of data analysis in his tutelage. It's his birthday today, so I thought I'll make a video on a couple of topics that he taught me almost 14 years ago using Minitab. As an extension of the previous video, this will let us explore what we can do with some of these statistical measures of data and how to obtain some insights from it. So let's begin. Now, first example, what we'll take a look at is two different teams' data. This data is for 52 weeks, that is for a year. And what we have here is the average team productivity in columns C and D. So column C, which is for Team North, and you have average productivity per day per associate for week 1 is 16 for Team North and is 19 for Team South. One common question that comes in with data like this in operational meetings or in terms of business meetings is how do these two teams compare against each other? To answer that question, one will have to look at some basic cuts of data, try and represent that effectively so that one can draw comparisons. One of the first steps that you can do as a part of your data analysis is to try and look at the different summary statistics that you can generate. In order to generate summary statistics, you can use the data analysis pack if you've installed it from add-ins within Excel, and we can begin with that. So generating this for North first and foremost. So if you go to data analysis and if you go to the option for, you will see an option in here, one for histogram and one for descriptive statistics. You can choose descriptive statistics here, and we've covered this in a previous video. I'll leave a link for this video as well. So let's first of all select the data set for North, and then where do we want the output range? So let's say we want to see the output. Let's say we want to place this output here, and from here, from the bottom section, from summary statistics till kth smallest, remember you'll have to select at least one. The one that we're interested in is summary statistics. So let's select that, click on OK. And what you'll see here is that it generates the summary statistics for us on screen. So this right here is the summary statistics for the North team. So we can just mention it here. And similarly, just like we have generated summary statistics for North, we can also generate summary statistics for the South team. Will work the same way. You go to the data analysis, choose descriptive stats, click on OK, and then make sure you change the range, because now we'll select the range for the South team right here. And then in terms of the output, we can simply, let's say, place the output right here in column H, keep it at summary statistics, which is already pre-selected because of when we selected the data for North. If you click on OK on this, it will generate the summary statistics for the South team as well. Okay, the column is extra, so we can remove it. There we are. We have a very, very clean and clear representation of summary statistics right here for the North and the South team. And now the question is, how do we use this, or how do we interpret it? So to begin with, one of the first questions that you will encounter is which team is doing better? Is the North team doing better than the South, or vice versa? So how do we decide if a team is doing better? One of the first things that you want to try and always look at is the mean. The mean, as you know, is the average value. It's a point of central tendency. So what you can clearly see right now from what you have on the screen is that in terms of productivity, North team's average productivity is at 20.25, as you can see here, while that of the Southern team is 17.25. So which team do you think has higher productivity? Well, by just looking at this, you can say that yes, on an average, Team North has had higher productivity for these 52 weeks. And then with that, you can make up the assessment that yes, given this data set, Team North definitely is doing better. But is that the end of our analysis? Well, not really. There is another thing that we need to always look at. So remember, while we've just looked at central tendency right now, and by central tendency we can see that the productivity for the north team is better. But then what about variance? What about the spread of productivity? Now, in regards to variance, remember that the lower the variance, the better it is. The lower the variance, the more the sign that the process is more standardized, that more or less people are following similar guidelines, similar SOPs, similar processing rules. On the other hand, if your variance is high, it could be indicative of one or two things. One, it could be indicative of the fact that within the same process, you have multiple different work types. And since you have multiple different work types, the productivity could very well be different for those work types. Also, you could have a mix of population. So maybe the team has some very tenured people with some very experienced people. As a result, you can see a lot of variance in productivity. The third thing could be a very different thing altogether, which is maybe there is less compliance with following an SOP or following process rules. And that's another possible aspect which leads to this variance in data. And this is what you would want to explore, all of these three possibilities to understand. So is high variance good? No, it's quite the reverse. So the lower the variance, the better it is. So how do these compare? How do these two teams compare in terms of variance? So in terms of variance, what you can see is that the standard deviation, if you look at the standard deviation, which is one common metric of looking at spread of data or dispersion, you can see that the standard deviation of Team South is much better. The standard deviation of Team South is much better as compared to the standard deviation of Team North. So while North appears to be more productive and most likely is more productive, but remember that South seems to have less spread of data, and the Team South appears to be either more compliant with the processes or more standardized. So this is a good start to the overall analysis, and this is one of the things that you want to try and look at. Now, the other thing that is definitely recommended when you're looking at any data which has an element of time in it is to look at a time series like data. So basically plot productivity over a period of time to see if there are any patterns that are visible within it. So let's see if there are any specific patterns that we can encounter. So one of the ways that you can do is by creating a simple line chart, a line chart that will allow you to compare both of these data sets and then probably help you draw some conclusions. So again, to create a line chart, if you just select this data set, you go to insert option, and from there, if you go to recommended charts, within recommended charts, it will on its own, Excel will on its own give you some recommendations. You could probably pick from that. So we're just going to pick a certain line chart out here, and we're going to utilize that line chart as an example of how to look at a time series like data set at a very preliminary level. So here we are, we have the line chart generated for us. So let's go ahead and take a look at it. All right, so this is, we can just call it productivity time series. Okay, so within the productivity time series, one of the things that you will immediately notice is that it validates some of our initial observations that we got from summary statistics. So just take a look at it. You'll see that Team North, which is marked in blue colored font, has much higher productivity. As you can see, the blue colored line is almost exclusively at every point higher above the orange colored line for South. What you'll also notice is something that we again saw from summary statistics, which is if you see the spread of the data distribution. So look at North. Do you see very rapid rises in these crests and troughs and very rapid drops? So there are very sharp rises and drops all along the way. Each of these sharp rises and drops represent variance or spread of data. And this clearly tells you that while on an average the team seems to be doing better, but it also is an indication of the fact that team has large amounts of variance within its own distribution. On the other hand, look at the orange colored worm, which represents the average productivity for Team South. Here what you'll notice is that the extent or the degree of variance is far less. There are peaks and troughs, but they are not as high in magnitude as compared to the one for the blue colored worm. So this is again ratification or ratification of validity of the fact that summary statistics had already pointed us in that direction, and now we also seen it visually. From the perspective of a presentation, if you're presenting to stakeholders, this might be a more effective way of showcasing these two different aspects: the higher central tendency for Team North and also the higher variance for Team North. By using graphical measures, a lot of stakeholders are more visually attuned, and this would probably help you prove your point or drive across any insights that you want to talk quickly and clearly to the various stakeholders. So now that we have begun with this sort of an analysis, the other thing that you can do is, just like you generated summary statistics, you can also create a histogram, and a histogram can also be an effective way for you to compare and understand this information. So remember that for any kind of data analysis, whether that's within core statistics or whether it's in applied business, whether it's in a field like using DMAC methodology or Six Sigma, you will find that any sort of data analysis will often begin with a graphical or visual representation of the data, because it helps clarify a lot of things intuitively and visually, making it very effective as a tool. So two things to always look at. One, you always want to look at the time series based variation in data. How does the data change over time? Are there any significant process shifts that you can find out, right? So all of these become extremely important narratives to look at from a visual standpoint. The other thing that you want to look at is the overall variance independent of data, right? And an example of the overall variance independent of data is often given by the sharpness of the rises and drops in the distribution of data. So now that we've looked at these two tools, let's look at another important aspect when you're looking at this data. So at a very fundamental level, it is good to bear in mind that whenever you're looking at multiple variables like X, Y, or X, Y, and Z, if you're dealing with continuous data set, meaning both variables X and Y, for instance, are continuous, then a scatter plot is a much more efficient way of looking at data. However, if you're looking at a combination, which is your variable X and your variable Y happens to be continuous or discrete, and not continuous. So let's say X is continuous and Y is discrete, or X is discrete and Y is continuous. In those cases, something known as a dot plot, also in some texts referred to as a stratified frequency plot, can be an extremely effective tool for us to understand and look at some of this data. So a dot plot is, by those who are experienced in data analysis, is used quite a lot. Sometimes people tend to overlook it, but for small size or medium size data, even today, a dot plot can be a very effective way of looking at several important things. It can actually help you with important insights if you're looking at a dot plot. So a dot plot can be made in different applications. You can make it in R, you can program it in R, you can make it in Python, you can create dot plots in any of the known statistical packages like the one I had used at the very start of my own career, which was with Minitab, but you can also make it on JMP, SPSS, any tool, and you can also come up with similar formulations within Excel to create a dot plot. And again, dot plot can be fairly effective. In order to make the rudimentary dot plot out here, what we're going to do is we're just going to first of all just copy this data set out here. And once we have copied this data set out here, let me just insert a quick column in between them. And let's change the font size for easier visibility, so that we can understand what we are doing and you guys can follow along with that one. Okay, so we just copied the data set from the left to the right, and now what we want to do is we want to just sort this data set. Okay, now remember that last time when we were looking at a comparison, we were doing a time series, In this case, now when we are going to make a dot plot, we are not looking at time series. We are not, so this look at the variance of data is going to be independent of time. So what I'm going to do is I'm going to just sort it and arrange this data so that it makes it easier for us to do that. And to sort it, you can use the simple internal sort function within Excel from sort and filter option. And let's sort it from smallest to largest. And again, for data for Team South, again, let's sort it again, sort and filter option, and we're going to sort it again from smallest to largest. Okay, once this sorting is done, what we want to do is we want to generate a count for each data point. So for instance, if you see data point 16 appears 4 times, data point 17 appears probably 5 times, then appears 18. So what we want to do in order to generate the dot plot is create the count for each of these data points. And in order to generate the count, what we can do is on this one, we can simply go ahead and let's say we start off with the count of, let's say we start off with the count of 1, for example. And then what we want to do is we want to compare that if the current data point is equal to the previous data point, what you can do is you can just increase the existing count by 1. So in other words, this becomes a counter. And then if the two data points are not the same, for instance, if you're transitioning from 16 to a 17 or 17 to an 18, what you want to do is again initialize that variable with 1. So then it's going to look like this. And now all that we have to do is we have to just drag it all the way to the bottom. You'll see the net effect of this. So we start off with 16, the count starts with 1, 2, 3, 4. The moment we go to the data point 17, it will again initialize with 1. Keep counting all the way till we reach the next data point, which is 18. It will again initialize and keep counting. So this is the net effect of what we have done just right now. Okay, now we will do the same for Team South as well. And again, generating this formula out here, and we can just simply go ahead and drag all the way to the bottom. Now remember that even though we are generating a dot plot, here the functionality that we'll be using for generating a dot plot is going to be the scatter plot diagram within Excel. So remember that the purpose is to generate a dot plot using a scatter plot. And again, please don't be confused with this. Remember that generally speaking, scatter plots are used when both of your X variables and your Y variables are numeric, right? And in this case, since we are trying to generate data for, if you see north, that's numeric. And if you see count, that is also numeric. That's why we are using a scatter plot for this. So again, so once we have developed this, now let's use a scatter plot and you'll see the picture emerge shortly. So with this, let's now generate the scatter plot for this. So if you again go to insert, you'll see recommended charts. Within the recommended charts, what you can do is if you look at all charts, for instance, and look at the option for scatter, and within scatter there are 2 options. Let's use the one on the right that we have and click on OK. And now what you'll see is Excel has generated a scatter plot version for us for Team North, right? So let's go ahead and put this here right next to it. So this is the scatter plot, but this is how a dot plot would look like. Okay, so essentially what we have done is using a scatter plot, we have generated a dot plot within Excel. Okay, and this is how a dot plot looks like. Essentially, you can see that within the dot plot, each dot represents a unique data point. Each dot represents a unique data point. The position of the dot along the x-axis, if you see. So the position of the dot along the x-axis gives you the data value of that point. So for example, for this dot right here, the data value of this dot, I'll just mark it just for an explanation. So the red colored dot that you're seeing right now, that red colored dot has a value of 16, right? And the count of this is 1. So this is the first data point with the value 16. If you look at the next data point right above this one, and again, I'll just color code this one slightly differently. This data point again, so this one's again showing in yellow. now. So this data point, if you see, this data point again has the value of 16, but this is the second data point with the value of 16. Then this one is the third and the fourth. So if you remember, we had 4 data points with the value 16. So that's why you have 4 data points above the x-axis value of 16. Similarly, if you look at 17, we had 6 data points with the value of 17. So now you will see right next to 16, you have now 6 data points, 1, 2, 3, 4, 5, 6 with the value of 17. So this is how a dot plot looks like. And you will immediately notice the benefit of this. So the benefit of this, if you look at the dot plot clearly, is that one, it gives you the shape of data. So remember that when you're looking at a frequency polygon or a histogram, it also tells you the shape of data. In this case also, the dot plot gives you the shape of data. So what you'll notice is that roughly this is how this data set kind of looks like. Right? So this is how this data set appears. And now we have the shape of data as well. What you will immediately notice is this data set almost is bimodal. It's not perfectly bimodal, but you see that that it has 2 local maxima. So there is one local maxima on the left and there is one local maxima on the right hand side. This almost makes you feel like as if you're looking at data for 2 different teams or 2 different sub processes. So this is a very important thing for you to bear in mind whenever you're analyzing this information. Just keep in mind that if you see data which is multimodal or bimodal, there could actually be differences being created by different processes or different or vastly different tenures between the same team members, or it could also be in some rare cases it could also be high degree of non-compliance with SOPs. But this is an important and critical insight that we've just seen with the dot plot. Okay, so now that we have seen this, let's go ahead and also observe that the dot plot can also help you gain a sense of the skewness of the data. It can also help you understand if the data is roughly normal or not, right? So let's go ahead and take a look at the dot plot for the team south. This is the dot plot for team north. Okay, just to make sure that we can have the right sort of comparison, let me just switch on the charger. So in order to make sure that we have the right sort of comparison, let's just make sure that we fix the range right here. So in order to fix the range right here, what we can do on this one is let's go ahead and select the range from 10 to 30. Okay, so it has now centrally moved some of this data, so you can see data points all the way from 10 to 30 on this, right? And this is for team north that we are looking at this data right now. Okay, so there we are, team north. So this is how the dot plot will kind of look like. Now let's generate this dot plot for team south as well. So in order to generate the dot plot for team south, again the same steps, which is make sure that you have selected the right data range. You can go to insert, recommended charts. Within recommended charts, again the chart that we want to choose is the one for scatter. Let's go with the option on the right and click OK. So now this will generate a scatter plot for us, which is in effect serving as a dot plot in this example. Okay, remember what is the other name for dot plot? It is a stratified frequency plot. That's the other name. So let's align these so that we can kind of visually compare how these two are looking like. Okay, and again this is the plot for team south. So let's go ahead and call it team south. And then remember the range we had selected for the x-axis was from 10 till 30. So let's go ahead and make that change so that we have a fairly equitable comparison point. So let's go to format axis and change this from 10 till 30. If you remember the bounds of the x-axis that we have for team north, this is what we are looking at, and there we are. So this is from 10 to 30. Let's just make sure this is also the same range. Okay, so there is a slight difference. Let's make it 10 till 30. And on the major axis, we'll keep it as, let's keep the major axis as 2, right? And then let's keep the major axis for team south also as 2. So you can simply go to format axis, and from format axis you can change the units for the major axis as 2.0. Okay, there we are. Now you will see that you have a much more clear depiction of this data. So now let's go ahead and expand it a bit. Okay, I hope it is visible on screen. We can simply go ahead and color code it differently. Okay, all right, so now if you notice, you will see immediately that it gives us a lot of information about the comparison of both the data sets. First thing that you'll notice is that the spread of data is much more in the north. Now you already know this from the summary stats as well, and you also know this aspect from when we were looking at the time distribution. If you remember, on the line graph for time distribution, we had wide amount of variance in the data for team north. And on the dot plot, you can see it by how broad the overall distribution is, between 16 to 26. While on the other hand, if you look at team south, you will notice that team south is much more closely clustered. And while team south does not exactly look like a normal distribution, but this is much more similar to a bell curved or a Gaussian distribution curve. So if you look at this, when we were drawing the curve on this, so this is roughly how it is. It is almost bimodal. There are two peaks here, and this does not exactly look like this is a bell-shaped curve or a normal distribution. But look at the curve for the team south. So this is much more bell-shaped as compared to team north. So immediately you know that for team south, you're probably looking at a much more standardized process. All the data points are more closely clustered together. In general, remember this rule of thumb: the less the variance, the better it is. The higher the variance, the worse it is. So one of our objectives when you're trying to take action in terms of improving a team's performance is to try and reduce the variance and to increase the average or the mean performance. So if you remember, north has much better mean as compared to south, right? In the previous example that we are looking at, right? Not necessarily the same here because these two data sets might not be the same, right? But this is a good representation of this information in terms of spread of variance. So this will again be very helpful, useful for you for depicting the trends or the patterns within data for these two teams. Okay, so now that we have looked at dot plots, let's move on to another tool which is commonly used. Now, this tool that we're going to look at now and is commonly used is usually referred to as the Boxplot, a very common tool. The Boxplot sometimes is also known as box and whisker, and there's a reason why it's called box and whisker. So basically, a boxplot is nothing but a graphical or a visual representation of the 5-point summary. Now, if you recall from our last video, 5-point summary is nothing but it talks about these things. It talks about the minimum in a data set. Then after minimum, the next point that you have is the first quartile. Then you have the second quartile, Q2, also known as the median, right? Then you have the third quartile, and then you have the maximum. So remember that that's what a 5-point summary is for any given data set. And if you had to generate a 5-point summary of the data set, how would you go about doing that? So the way you would generate a 5-point summary is, obviously you can use formulas. So for instance, let's say for team north and team south, let us quickly generate the 5-point summary using the Excel formulas. So in order to do that, we can simply select the right data range for north, and we have the minimum value here. Let's just slightly increase the font for readability purposes. And now similarly for south, this would be the minimum. Now let's quickly do the first quartile for this. The first quartile, select the data range, option 1, that gives you the first quartile. Let's do the first quartile for south also. Now let's do the median. You can do quartile 2, or you could just directly type in the median formula as well. Both will work, give you the same response. Let's generate quartile 3 on the same data set. Select the data set, select quartile 3, and you have quartile 3. And finally, let's go ahead and generate the max as well. So the max, you can directly use the max formula, select the range, and you have the max for north, and now you have the max for south. What you see immediately is we have quickly generated the 5-point summary for teams north and south. What you can also do is, for good measure, we can also throw in the mean. So what is the mean? The mean is the average. The average for team north productivity is this number right here. Okay, and let's just format it, and then let's generate the mean for team south as well. So we select the data range right here, and we have the mean value right there. Okay, so as you can see, well, the mean for both of these data sets is the same, and the median for both of these data sets is also the same. So then, if we were ever asked a question on which team is doing better, is north doing better, is south doing better, remember that you might not be able to decide the answer to this question by just looking at a comparison of averages. In this case, what you would want to then do is look at the spread of data. So one way that you can go about that is by looking at the standard deviation, as we have discussed in the past, which is great. But then, think of it in terms of presentation. If you are trying to present this data, or even if you're not trying to present it, if you're just trying to look at it yourself and try and draw some visual insights from it, how would you go about doing this? So one of the things that you can do is you can try and generate a box and whisker plot. If you make a box and whisker plot, it's a good depiction of the spread of data. It can also tell you about skewness of data. It can show you where are outliers, and it can also help you compare two or more than two different data sets very quickly, showing you a summarized version of everything we've just talked about. So how can we do this? The way we can do this within Excel is by using stacked charts. Stacked chart is an internal chart within Excel. You can use that. Remember that this happens much quicker and much faster in specialized statistical softwares like JMP, Minitab. You can make this in R. There's a specialized function in R to develop this, and you can do this in R, Python in multiple different ways. Okay, so how is this going to work basically? So basically, the way this sort of a thing is going to function or work is, if you make up a stack chart, then you can create it. But how would a stack chart function for us in this case? So in order to make a stack chart, what we do is, first of all, we make the outline of that box. Now, the outline of this box, remember, the box is going to start essentially from Q1. Now we already have the value of Q1. So what we'll do is we'll include everything from Q1 to Q3 within a box, and above that we'll not put a box, we'll just put whiskers. Okay, and basically a whisker is like a signaling thread, or like a straight line with a top that kind of gives you the spread of data, but not in the form of a box. So we'll start off with Q1. Now from Q1, the next point is going to be the median, right? So median to Q1, what is the width of the data set from median to Q1? So the width of the data set from median to Q1 is going to be 20 minus 18 for north, and it is going to be 19 minus 20 for south, right? So let's go ahead and do that. So this is the median and this is the Q1 value, right? Now, what do we have after median? So after median, you again have Q3, correct? So from Q3 all the way till median, Q3 to median, that's going to be our next range. So how would this work? So basically Q3 is 23 and your median is 20. So the difference between Q3 and median is 3 for team north. Let me just change the font size a bit so that we don't have challenges on screen seeing this. Now for team south, again, Q3 to median, what is the gap? Q3 is 21 and the median is 20. So this is our gap. So now what we have done here quickly is we have generated the different ranges from Q1 till median and from Q3 till median. So how would this help us? So the way this sort of a thing could probably help us is in developing the stack chart that we just referred to. So in order to create that stack chart, what we can do here is, for instance, if we were to select this, go to insert, within insert go to recommended charts, and within recommended charts you will see that there is an option that we have for stack charts. You can simply select the stack chart. There we are. Okay, so this is a stack chart and this is what we're going to convert into the box plot or the box and whisker plot. So how do we convert it? Okay, well, we don't need this legend, so we can remove this one. So now we just left with the two team names of North and South. So remember that we will only show inside the box the data from Q1 till Q3. So anything less than Q1 will not show inside the box. Anything greater than Q3 also we will not show inside the box. Okay, so what we do is we're going to make this box right here transparent. Okay, so if you just click on this part, if you go to fill on this one, we can just select no fill, and we can also select no outline. So now you see that the box which was representing data till Q1 is gone, and now you only have data points between Q1. So the lower edge of this orange colored box represents Q1 for us. The interface between the gray and the orange colored box is your median. As you can see on the left side also, the median is 20. You see that the line at 20 cuts through the gray and the orange colored box clearly. So this is the median. This straight line represents the median. And the top edge of the gray colored box, what does that represent? That represents Q3 for us. All right. So now that we have the structure available for this, what do we need to do next? Next, what we need to do is put up the whiskers. Now the whiskers are basically going to be your straight lines with a cap at the top and at the bottom, right? Now, in order to do that, what we can also quickly do on this is let's just make sure that we give it the right range. So let's just format the axis. Since this is only till 25, let's go ahead and make this till 30 in our representation. Okay, so we have this 30. So okay, this is going to work for us now. Now the next step for us is to add the whiskers. So how do we add the whiskers to this? In order to add the whiskers, first thing is for us to calculate the whiskers. So let's say we are doing the top whisker now. So the top whisker for us is going to be what? The top whisker for us is going to be the difference between the maximum data point and Q3. So our top whisker for us is 3 for north and 2 for south. Now let's compute the down whisker. The down whisker for us is going to be the difference between the Q1 value and the minimum value of that data set. So there we have the down whiskers. Okay, so now that we have the down whiskers on this, our next job is to add these whiskers to the graph so that's visible. In order to do that, we'll use the add chart component option within Excel. So what you can do is let's add the top whisker first. So basically, remember the top whisker for north is 3, as you can see here. So here on this side, we'll make a straight line segment of the length 3 and add it to the top of the graph. So in order to do that, just click on this section first. And once you do that, so go to chart design. Within chart design, there's an option called add chart element. Click there, go to the error bars. Within the error bars, scroll down to the bottom where you see an option for more error bar options. If you click on that, now the first thing we'll select is the direction. Remember, it gives you the direction as both minus plus. In this case, we just want plus. Do we want a cap? Yes, we want a cap. And we want a specific custom value. The value that we want is the value that we created for the top whisker. Since we have chosen the option of positive since it's going to be directionally pointed upward, in the positive error value, what we do is we select the top whisker values here, right, which is 3 and 2. Once you've done that, what you'll notice is you have the whiskers now appearing on the graph. As you can see here, you have the whiskers out here, right? And the whisker kind of tells you the top value. So this this thing at the top is the max value, represents the max value of the whisker. Similarly, what we can do is we can generate a whisker for the bottom value as well. You can go back to adding chart elements. You can go back to the error bars out here. So let's start again. So you can select this. You can go to add chart element. You can go to error bars. You can go to more error bar options. This time, what you want to do is choose the option for a minus because you want it pointing directionally downward. Choose the option for custom and then select value. Remember that this time it will be the negative error value you want to select, and that is for the down whisker. So select this data range for down whisker, click on OK, and there you are. You now have the down whiskers available to us. Okay, so this is how a box plot or a box and whisker plot looks like. This is a very, very visually helpful plot. By just looking at it, what you can see is that for one, do you see that median is same for both? You can already see that the median is the same for both of these data sets because they fall on the same straight line. What you can also see clearly from this data set is that the width of the data is far more for north. You already know this from the last a couple of different charts and formulations we looked at. Also, the width of data is much less for the south team. So team south seems to be much more standardized. In the event that the central tendency point, the mean, the median is the same for both the distributions, we can always say team south is doing better because team south has less variation as compared to team north. Also, on a box and whisker plot, these lines that you can see also show you the range beyond which you will have outliers. Basically, anything that falls beyond this area is then going to be anything outside the box technically could start tending towards being an outlier. Outliers is again a topic that we'll cover in a different video, but remember there is a very specific method by which you can calculate outliers. In fact, there are a couple of different methods and we'll consider those separately in another video. But then in a box plot, traditionally when you make a box plot, say on Minitab for instance, you will often see that wherever there are outliers, they are usually marked on the chart with an asterisk mark. So if you're looking at a box and whisker plot, you see an asterisk, that means it's an outlier. And it could be either a upper outlier or a lower outlier depending upon where it is. Also, traditionally in a lot of softwares, when you look at the box plot, you will not see differential color coding. You'll probably see that both these boxes are of the same color. But eventually, this kind of gives you a good representation of the variance of data, and this is an interesting way of comparing multiple teams at one glance to see how the teams are performing. Another important thing about the box and whisker representation looking at is it can also tell you important information about whether the data is kind of skewed or not. The reason I'm saying that is if you look at this data set, look at it for north, for instance. So if you look at north, and what we can do is if you were to just try and draw a graph, a rough graph from here, like this, what you'll notice is that the data set is broader on the right hand side. If you notice, right, the data set is broader on the right hand side, and it is much lesser on the left hand side. So it kind of tells you about the skewness of the data set as well, right? So this is another way of looking at it. However, if you look at Team South, you'll see that it's virtually similar. I know the space is less, but if you were to draw the graph like this, you will see that this is almost more bell-shaped or more Gaussian in distribution than what you're seeing for Team North. So however, having said that, the box plot is a very, very helpful representation. It can quickly allow you to compare two different distributions in terms of the 5-point summary. And visually, if you're trying to show this to a stakeholder, I think they will appreciate this much more than just raw set of data points out here, right? So a quick recap of what we looked at in terms of the dot plots and the box plots. Remember that dot plots, again, used for representations where one variable is x and the other one is discrete. If both were continuous, then you want to use scatter plot. They can tell you about the spread of data, the shape of data as well. It retains the count of the data points, which can be very helpful. It can help you identify different clusters of data and then compare the clusters of data. One thing to bear in mind is, because for every data point you have a dot, if you're dealing with a very large data set where you're looking at hundreds and hundreds of data points, there using a dot plot might be very cumbersome and unwieldy, because remember, you'll have as many data points as you have, as many dots you will have on screen. Might be difficult. Box plots, again, remember 5-point summary. Box plot is excellent for summarization of data. It is also great for visualizing outliers, often shown with asterisk marks. You can compare two different data sets. You can visualize the shape of data also, if you know how to interpret it. You can see if the data is skewed or not. And again, remember that if you're not trying to summarize or look at a summary of data, then maybe you don't want to look at a box plot. Maybe then the tool you want to use is a different one. So this kind of brings us to the end of this video. Hopefully this was informational and informative as well. So in the next video, we'll try and then move on to some of the other statistical tools. I'd just like to take a quick moment to thank all of you who do watch these videos. And again, thanks to everybody who has subscribed to the channel. Appreciate it. Have a great day. Thanks, everyone.